Okay, sweet.
You ready to start?
Okay, very good. Okay.
Oh yeah, if you need the scratch paper, it's this one.
Oh no, I don't need to describe.
You don't need?
I want to reduce.
Oh, you want to make it
I will,
so it's these ones, so this is zoom out.
Mhm.
You want to go out? Or
Yeah,
in?
yeah.
Like that?
No, out.
One more?
Yeah.
More?
Okay.
Or, that's good?
Yeah, that's good. Yeah. Okay. This is a structural analysis portion. When did you have your structural analysis lectures in the school? How long ago was it? About 2 years ago. Okay. Where did you go to school?
Long
Calcutta Long Beach. Who taught the course? Forgot the name. A lot of part-time people too. You know. Yeah, that's okay. Okay, I just asked. There is another person taking from Chicago. She is in construction. You are in transportation, correct? Okay. We are in structural analysis and structural design. We are going to talk today on structural analysis. Structural design is a very complicated subject, but I don't. There is a chapter there in this both concrete and steel, so I'm not going to cover that. For next time, see, designs are very difficult because designs are just not simple. There's a lot of factor of safeties, many things. Designs are kind of complicated, and really that's what real life is. Unfortunately, we have what is called a factor of safety. So, a long time ago, the factor of safety supposed to take unknown issues into account so that the structures stand up. But the big problems are like floods and earthquakes. We can't really design structures so that they stand up. Anyway, that I think you can do it, but somehow it costs more money or something, and so they don't bother about it. And that creates a lot of problems for society. We have floods damage in Texas, New Orleans, and all those places recently, and we have fire going on right now in California. So really, if a big earthquake comes in California, we have maybe 100 billion damage. I can't even predict how bad it will be. But anyway, okay, this is kind of generalization. In your exam, what you are going to take is CBT and CES exam. There are 6 to 9 problems in the analysis of structural analysis. Right? 6 to 9 problems. That's quite a few. Not out of 100 and how many problems we have? 55 in the morning, 55 in the afternoon. Out of 110. 110 problems. 6 to 9 problems. So that's you have to know this. In the analysis, the specifications mentioned to you, item 12 in the NCES. NCES is they are the people who make the exam, set up the rules and all. So there are 5 items in the analysis. Analysis of force in the statically determinate beams, trusses, and frames. Quite a few. Statically determinate, right? Statically determinate means you don't need any other information except the statics equations. Except statics equations. And then the deflections, analysis of the forces and the deflections. Statically indeterminate beams, trusses and frames. very general description. Structural determinacy, structural determinacy and stability analysis of beams, trusses, and frames. Determinants, and then the loads and load paths, blah blah blah, and all. Elementary statical indeterminate structures. So it really covers a kind of very wide area. And the books what we are using, I am using my own notes, which is which. Did you get a copy of this? You didn't get a copy of this? Huh. I asked him to distribute it. Yeah, just a minute, I don't know why. Okay. Oh. Okay. So the other guy who left, you didn't give him a copy. Yeah. Anyway, this is the copyrighted material, you know. So my things are here. Okay. In the handout which I gave you, chapter 1, there are 10 chapters, and if you are good at these, then you will have no problems in answering the questions in the exam. And so that's what the notes, and then the NCS formulas. On page 151 to 152 of your NCS handbook, there are formulas related to this in the handbook. So you can take a fast look at it. I made a copy of it myself, page 151 to 152. And then the 153, that's concrete and steel. So that's different. Only 2 pages for this analysis. And definitely you should look into the formulas, because the exam, this book is available to you on the computer, on your computer, exam computer, and so in other words, there is a chances there will be problems on this basis. If there is no formulas given in the handbook, normally they can't ask questions. Okay, now, so these are the formulas on page 151 and 152, and then there are 7 sample problems, NCE's sample problems, and 7 problems, solutions. And this is very important to go through all the problems, 7 problems, because your exam will be somewhat similar to that. So we'll cover the material. After that, we'll go through the sample problems. If you have any questions, by all means, let me know. I will go back and discuss that. Okay. So we'll get out of this. Okay. Any questions?
You want to put this on?
Yeah. I want to show one more page.
One more page?
No.
Oh, zoom out?
Yeah, zoom. Yeah. Zoom out.
Down?
Yeah, no, further.
Further?
Oh, this one?
Yeah.
This one?
That zooms in.
Okay. So now the books, the standard books for structural analysis, I don't know what books they are using now in universities. Analysis is from many years. A long time ago, I used to use Tung Au. That's a very good book. Tung Au. And our Kinney also a very good book, but this mostly indeterminate structures. Wilbur and Norris is very common. What do you know? What book you used at Cal State Long Beach? Book, the textbook. Yeah. Anyway, do you have the book at all, or at your home?
Yeah.
You have. Okay. Anyway, so refer to that in case or something. So read this. Okay. Now, coming back to say, read the introduction by yourself. Basically, in structures we have trusses, we have beams, we have frames, we have walls, we have a shear wall. A wall is basically it takes care of the vertical loads, but the earthquake issues, because the force are lateral forces, the walls take a shear. This is called shear wall. And this is a frame, wall, and beam. Also, then you have next step is the slabs and the diaphragms. Slabs means it's a 2D x and y, and the loads are acting like this, perpendicular to the slab, just like all the floor loads. And then another thing, when the slab, we call them as diaphragm when the forces are applied in a lateral way. Lateral force are applied. When do lateral force applied? Wind analysis, wind, the lateral force. Earthquake is a big lateral force. Earthquake, when the building vibrates in the horizontal direction, it takes inertial force. There's the mass times the acceleration in the forces that are coming to the diaphragm, and they go to the columns and so on and so forth. Once these forces are coming in, then those forces are transmitted through the structure. So in this way, one is axial force. There is N is called a notation or a PRS. Bending moment M, shearing force V, torsion T. Torsion is not very much in civil engineering. The force is normally in mechanical engineering is mostly torsion. All these pumps and turbines and shafts and all those things. So now these are the forces. So what happens? One of the questions would be, some load is applied. You are supposed to find the internal forces. After the internal force is applied, a force N, that there will be stresses, P over A, stress, bending moment stress MC over I, VQ over IB, TR over J. You must remember this in your mind, all the time, the formulas. P over A, MC over I, VQ over IB, TR over J. These stresses will cause deformations. When you say deformations, it is total extension. If you apply a force N, the deflection would be at delta equal to PL over AE. And then if a bending moment is applied, the angle rotation would be mdx over EI, VQ over IB, and then the TL over GG. So these formulas, I have to remember these by heart. So what happens after the loads are applied? The loads go as internal forces. Loads cause internal forces. Internal forces cause deformations. The deformations are internal, you can't see them. But what you see is the correct displacement. This is the deformation and this is the displacement. Displacement is what you can see. If I have a truss, you can see the deflection of delta. If you have a beam, this angle change. For frame, it will be, these are the displacements. For axial force, delta V, and for the lateral force, delta, these are the forces. Then in a 2D, in the two-dimensional thing, this is not even covered in the basic undergraduate subjects. Plates and shells are in the master's level. So this is really the whole sort of